Students and friends, welcome to my YouTube channel. Today I am going to discuss the problem for the deflection of cantilever beam with a UDL of the entire span. So, like these questions, if you know the formula, we can answer. So, here derivations also I kept for you. So, what is this one? Cantilever beam means one end fixed, other is free. All the boundary conditions is there. We derived this equation in the previous video. We got the slope WL cube by 6I, or if you take the total load nothing but UDL load plus UDL load into length. So WL square by 6EI. Similarly, deflections also we got WL cube by 80I. Negative sign indicates deflections and slope will be downward directions. Okay, I wrote here downward, but numerically once it will solve question, we'll write the positive value. Formula will write in the positive. So one model problems I taken here. What is a cantilever beam of 120 mm dia, 1 wide. So that means B is 120 mm and 20 mm deep. So D equal to 200 mm, not 20. And length will be given, okay, length I am writing here, length they given 2.5 meter. If you will convert into mm, multiply 1000, 2500 mm length will be there. Okay, now what will be the uniformly distributed load? They are asking W. What is W? W nothing but per unit length. When the deflection is the given free end, deflection is free end, that means YB is equal to 5 mm given, and E given. What is E given? 200 giga-Newton per meter square. This we have to convert here. So 200 giga means 10 power 9 Newton per meter square. Now if we will convert into mm, what we will do? So we know that 1 meter is equal to 1000 mm. So 1 meter square is there here. So 1 meter square is equal to nothing but 1000 mm square. So it will come 10 power 6 mm square. So what will write here? Directly will write here. Look here. If you will write here, okay, one more step we are writing. 200 into 10 power 9 divided by 10 power 6. So it will come Newton per mm square. If you will solve here, 3 plus 2, 5. So 10 power 5 Newton per mm square, you will get the value of the Young modulus. Value of the Young modulus we know. Now what they are asking here, W they are asking. What is the W here? We will write now per unit length in Newton. W nothing but what is per unit UDL per unit length, per unit length in Newton. So this is W here. So that only we have to find out. So deflections they given here. So if you write the deflections formula here, Y deflection is nothing Y. So YB, because they are asking at the free end. YB, what is the formula? If we will take the capital W, okay, capital W I am taking. So then we will take L cube by 8 EI. Then what is the capital W here? Capital W we can write W into L. See here. Suppose this is the per unit length is there. If we will make the W, that is total load. Load will be nothing but W into L. So W into L will write here now. What will write? W into L. Okay, this W, you know. So this capital W is equal to W into L. Yes. W into L. L cube by 8 EI. We can write like this. Okay, now we'll substitute this value. So YB given how much here? 5 mm. 5 mm. This W as it is. Length will be 2.5. because this per unit length, this length will take in meter. This length will take in meter. So 2.5. Then another length will be 2500 power 3. Will be here 8 into E. E how much? 2 into 10 power 5. Then I. I we have to calculate. I is nothing but B D cube by 12. So what is B here? 120 into D is 200 power 3 by 12. If we'll solve it, this is coming how much we calculated already. I will be 8 into 10 power 7. 8 into 10 power 7 mm power 4, because mm, this is mm cube, so mm power 4. So we'll write here 8 into 10 power 7. So now we'll look here. We'll check the formula. Check the what is unit cam for W. So this is mm. Somewhere we'll write, okay. You see here mm. Now this is W. This is meter. This is mm cube. Mm cube. Here Newton per mm square. This is mm power 4. Now look here. 1 mm get cancelled. So here 2 mm will be there. And this mm will go top. So this 4. So this will get cancelled. So what is W unit is coming here? Newton will come this side. Newton will come this side. Meter will come this side. So this is the W unit. This is the W unit will come. So once we'll calculate this, big value will come. So some value will come here. Kilonewton per meter. Kilonewton per meter. What value? This is W value will come here. So this, if we'll calculate this, how much value W is there? W 16.384. 16.384. Because it is coming Newton meter. So big value will come. So divide by 1000 na kilonewton per meter. This is the W value we are getting here. So this way we can solve the questions. Okay. So once we'll check here. B they given, dia they given, length they given, YB there, they are asking the deflection. Deflection is nothing but per unit length in Newton. So we'll convert into load na. What will come here? Capital W is equal to W into L. So W into L, this Q is there. So W into L is this L power 4. So if we'll take capital W, L power 3. So this way we can calculate the solutions. Okay. Okay, students. Thank you. Watch the video. Subscribe the channels.